Okay, today we're going to look at how the x and the y value changes result in a change in the graph of different functions, and we're going to look at a number of different changes depending on how a number is added into an expression. So if you look at the first shift we're going to look at, it's called a vertical shift. What happens when we add or subtract a number? And you might have a good idea of what happens already from your previous math experience. Let's take a look at some graphs here. We have the graph of y equals x squared minus 5x. That's the one that you see. What is going to happen to this graph when I add 10? And then what is going to happen to this graph when I subtract 10? How is it going to change? Well, let's take a look at the second graph first. We see that comparing this graph to the original graph and using the vertex as a reference, there is the vertex for the shifted graph, and this is the vertex for the original graph. It has moved up, and it's moved up 10 units because the C value is plus 10. If we look at the third graph, which is down here, and we look at its vertex, it has been moved down 10. A vertical shift is when the graph moves up or down, and that's the only part of it that changes. So this value, if it's added or subtracted at the end of a function, changes the y value by the amount that it is. Horizontal shifts are referring to the x values, and you may have heard them called phase shifts before in the context of sine, cosine, and tangent functions. With regards to the horizontal shift, let's just again take a look here. We have a line. The line is 5x minus 2. What happens to that when I add 4 to my x value? How do I compare the two graphs? So let's just get them side by side here. Well, what has changed? Well, if I look at this intercept right here compared to the original intercept right there, it has gone from being at, looks like at about 1 to being at minus 3. So it has been shifted 4 to the left, a horizontal shift. And with your x values, you find opposites, that if it's plus 4 in the brackets, it means you're really subtracting a minus for moving it to the left. And if we look at the third equation, which is not plus 4 but minus 4, and I'll use green to highlight that there. Minus 4 means we move 4 to the right, comparing it to the original blue x-intercept. And so that is the horizontal shift. So what we're going to be looking at today is how does that affect certain points. So if we look at the point P, which is minus 6 and 12, and we're going to find the new point of P. If it's x minus 5, f of x minus 5, that means the x value is changing. But it's subtracting a positive, so you add 5 to the x coordinate. The y value is not changing. When does the y value change? When you add or subtract that c value that we talked about originally. So that changes your y value to being, well, keep the x value the same now. Your y value goes down 5. Not the opposite, the same as the function that you see, subtracting 5. For x plus 5, again, let's use point R this time, which is right here. And what happens when you have x plus 5? Well, that means your x coordinate is going to go down 5, so it becomes minus 8. There is no number added or subtracted, so the y value stays the same. We're also going to look at some other shifts, including vertical stretches and vertical compression. Stretch means to stretch out, compression means to make kind of push together. So let's take a look at some graphs here. We have the original graph, x squared minus 2x minus 15. And we have the new graph where we're timesing it by 3. How do you, or what appears to happen to it vertically? Well, it would appear that it's become more narrow or been stretched out vertically. It's like you took the one end and you just pulled it tighter, and that has been stretched. And that's what happens when you have a number multiplied by your function, that it's going to get bigger faster. So it becomes stretched. Similarly, when you multiply a function by a fraction, if we compare, let me grab this graph. If we grab this graph and compare it to the original, it's like it's been compressed vertically or squished. It's become wider. That's because it's getting bigger slower, and that is what happens vertically. Similarly with horizontal, we find the same thing that happened back here with our horizontal shifts, where it was the opposite of the operation with the x value. It's the same thing with these horizontal compressions and stretches. If we multiply by a number, it gets compressed. and if we divide or multiply by a fraction, it gets stretched out. So let's just see what that would look like. So here's a root function, a cube root function, the original. What happens when we times the x value by 4? How would you describe that? Has it been stretched or has it been pushed? And I would say, if you were to look from left to, or from right to left, it's like the graph has been pushed closer to the vertical axis. It's become more of a bump at this point compared to here. It's been compressed, whereas if we look at the third graph, this is my 1 times 4x. If we look at 1/4 multiplied by x, it's like the end of it on the right-hand side has been pulled, so that's been stretched out a little bit, and that's called a horizontal stretch. And similarly here, we look at, well, what happens to different points when we have these stretches or compressions. And with y values, what you see is what you get. With the x values, it's opposite. So if we look at, I'll pick point s this time to look at, which is originally 6 and 9. If we have 3 times the function, that means the y value is changing by a factor of 3. The new point s would be x value stays the same. Y value is multiplied by 3, so it'll be 6 and 27. If we look at point R and we look at for this one, well, the x value is changing. It's within the brackets. It's a 1/3 x, so that means it's being stretched, and it's the opposite. Instead of multiplying by 1/3, you're really going to change the x value by a factor of 3. So it becomes -9 and -3. And that theme just holds itself through the whole section, that what you see is what you get with the y values. With x's, you got to think opposites. And we find there's another change, which is reflection over the x-axis, and this is involving minus signs. Take my original function, make it negative, it flips over. But if I make my x negative, it does not flip over. So when we talk about reflections, if it's the whole function, it reflects over the x-axis. If I compare this graph, this parabola here, to our original parabola here, it has been reflected over the x-axis. When we look at the x value changing, it's tough to tell here because it looks like the same parabola, but really the sides have switched or reflected over the y-axis. So if we look at combinations, and I'll look at C here, f of x minus 2 plus 1, what is going to change when I look at point P? Well, the x value is going to change because something's happening inside the bracket, and the y value will also change, and point P will now become, if my x value is going to be added, or you're going to add 2 to your x value, and we're going to add 1 to our y value, we would get that. And then if I look at point R, and if I look at D here, well, the x value is multiplied by 3, but I remember, oh, it's opposites, so I'm not going to actually multiply by 3. It's going to become divided by 3, so -3 divided by 3 is -1. And what you see is what you get with the f of x, or the y value. 2 times that means I multiply my y value by 2. So you're not going to find it to be super hard. It's just going to take a little bit of practice, and you can see there are ones here that will require a little bit more work, and there are conclusions that can be made when we have minus signs. We have reflection, and because it's the y value, if we look right here, that means the x-axis is where it reflects. If it was the x value that's being multiplied by negative, it would be over the y-axis. And we're going to talk about all these things during your assignment. And we might do these examples to help you get along or get started. There's quite a few there. I don't want to do that now. And if you really want to get to your assignment, it is right there. So that's it. Lots of information. We're going to work together to make sure you understand what you're doing. Sorry that this one's a little longer, but it just took a little bit of time. I will see you soon.